Yusuf, Spare, and Giraffe. If you'd like to become a sponsor, you don't have to pay this much. This is for companies, but this is what pays for the pizza. So it all comes back to you. But if you'd like to talk to me about getting your company to give us some money, that we surely love that. The best way you can help this community is be a speaker, come to these events. Code of conduct, everyone treat people respectfully. If you feel like you have not been treated respectfully in any way, please come up to me and talk to me. If for some reason I'm the person who has treated you disrespectfully, ordinarily I have a quote, someone else, Yusuf, message him on Slack. Here are our links: Austin RB, refreshaustinslack.com, and Twitter. Does anyone have any announcements? I have one about Yusuf. He just had a baby, which is why he's not here today. But any Ruby announcements? Or Rails? All right.
Rails 6 is out. Use it.
Yeah, there you go. So intros, name company if you're hiring or looking, and the icebreaker is how you would talk about a carbonated, bubbly brown substance. So I'll give you an example. I'm Justin Mills. I work for People Admin. We are hiring. I'm not looking. I would call it soda. Annie?
Yeah, hello, my name is Annie. I work remotely for the University of Michigan. And I mainly work on Rails and React. And we're not hiring.
Wait, what's the icebreaker again?
The icebreaker is how you would say, if you wouldn't say soda, since that's been revealed now, what other term would you use?
Okay, so my name is Mark. I work for a company called Doximity. They are a medical network, and we are hiring, so if you are interested, definitely come talk to me. And let's see, I'd call it soda as well. So.
My name is David. I work for a company in town called Scale Factor. We are hiring. I actually just started as a junior dev there, so I'm not looking, but we do have some positions open. I guess I would probably call it soda.
Hi, my name is John, and I work at CareerPlug, and we are hiring. And I do call it soda now, but I think I used to call it pop at one point.
I'm Kanan. I also work at CareerPlug with John. We're hiring. I'm not looking. We're hiring also for like an engineering manager as well. So if anyone's interested in that, come talk to me. I'd love to talk to you. Yeah, I'm just gonna go with soda. That seems to be the hot ticket.
Yeah.
My name's Noah. I work for Cisco. We are hiring, but just for React, no Ruby. I call it pop because I'm from Chicago.
My name is Michelle. I work for Blackbaud. We are hiring both for an engineering manager and mid to senior Rails people. I am maybe looking. And let's see, I am from Massachusetts, so we call it tonic.
Hi, I'm Brett. I work for Procore. We are hiring quite a bit, primarily in senior and up roles. And I generally call it soda, but for the longest time I just called it Coke.
Hi, I'm Ben. I run from Page. We are hiring part-time contract junior Ruby on Rails. And I'm from Texas, and I call it Coke.
I'm Mike. I work for a small company in Phoenix. I work remotely as a Rails developer called ClearVoice, and we are not hiring. I'm not looking, and I'm a soda convert.
My name is Anne. I work remotely for Cover My Meds. We are
now, currently working with Ben part-time.
And I grew up in Oregon calling it pop, and likewise was shamed into calling it soda.
I'm Autumn. I work at a company called Equilywell. We are hiring for senior and above. We are Ruby React sort of shop. I am maybe looking, curious possibly, and I call it pop because I'm also from Chicago.
Wayne, I work for the Flatiron School. I think we're hiring, but I don't know for what. I'm not looking. I'm from New York, and I call it sweet, sweet friend of mine. That's it.
I'm Barbara. I work at NXP as an engineer. I don't think we're hiring. I'm also a student at Flatiron, doing some coaches there. I just call it Coke.
My name's Eric. So I just moved to Austin about a week ago to start at Pop as the development director. So we are hiring, but not for Rails. So if anyone's looking to do iOS, talk to me. Midwest roots, Chicago as well, so I would call it Pop.
Hello, my name is Deal. I work for Apple as a GIS technician right now. But I am looking for a job. And I call Coke.
My name's Aaron. As of next month, I'll be working at RigUp, so that's why I'm not looking. They are hiring. I'll know a lot more when I start. But they do primarily Ruby on Rails and React. There is some Angular that's getting moved into React. And I call it Pepsi. That's only because when I was a kid, Dad had a lot of Pepsi and I wasn't allowed to drink it. So I got very associated with the name of the thing that I wasn't allowed to.
All right. And you just walked in, so we're going to shame you into introducing yourself. Name, company, whether you're hiring, looking, and what you would call soda, pop, Coke, or Pepsi.
Oh, wow.
Or
That's a lot.
tonic.
So, name's Reza. Work for myself, independent contractor consultant, looking. And I would say Coke. Yeah.
All right, and by show of hands, is this the first time you've been to this meetup?
No.
All right. Yeah, keep coming back. We're here every fourth Tuesday. We also have an Austin RB, which is focused on Ruby stuff. On the second Monday, we're on Meetup. You can look us up. Later in the year, we have Thanksgiving and Christmas, so October is going to be our last Austin on Rails for the year. All right, and it's on to you now, Richard.
All right, thank you.
I have swag from O'Reilly who wants some pins, phone thingies, screen cleaners.
Or sheen stickers.
Sheet stickers and a code triage sticker.
Yeah, it's kind of bent code triage stickers.
Okay. Give me a second. It's all part of the show, folks. All right, so hello everyone. My name is Richard. On the internet, I go by Schneems, hence I have stickers that say Schneems. I know it's kind of weird to have a name of somebody else on your, electronics or something, but then I could pretend it was mine and steal it. Ask me about that later if you didn't hear the story earlier. So you should know that I love Ruby, so much in fact that I decided to marry her. This is my wife, her name is Ruby. We met at a Rails meetup, this Rails meetup. We have two beautiful children. These are my boys. One's initials are JS, and that does not stand for either Justin Searles or JavaScript. We have two dogs. One of them is currently missing, actually. She's been missing for about the last month. She ran away from a pet sitter. You don't need to know that. It's a happy talk. We're gonna focus on a happy place. We still see her. There's like a Nest Cam. We know she's alive. We still see her. She just runs really fast, and we have no idea where she's hiding during the day. Anyway, that's not part of my talk, but this is. So this is my other dog. His name is Hans Peter von Wolf V, which is a lot of words to say. So we just call him I have words here, I totally skipped them. So that is his actual name. My grandfather was the first, or great-grandfather was the first person to have a dachshund named Hans Peter von Wolf, so he is actually the fifth. But it's really hard to yell, so instead we just call him Cinco. Yeah. I run a service called Code Triage. It's the easiest way to get started contributing to open source, and it can also send you documentation if you're interested in like getting patches. Ruby is the only language that it supports for documentation, mostly because I'm a Ruby developer. So there you go. I work for a small startup based out of San Francisco. I didn't do that working hiring thing. I mean, jobs.heroku.com, I guess. We're always hiring. I have no idea. I'm not currently looking. I've worked for them for about 7.5 years. They pay me to work on the Ruby build pack, which, has anybody used Heroku? Okay, so when you do git push Heroku master and all that stuff flies by your screen, like, you know, bundle install, rake assets, precompile, that's me furiously typing as fast as I possibly can. And so if you try it right now, it's just not gonna work. Before I get started, I do want to thank a couple of people who helped make this presentation possible. First, though, a little bit of a backstory. When I started writing this talk, if you follow me on Twitter, you might have seen that I hurt my hands pretty bad, like really, really bad. I had to take a couple of weeks off of work, and I did physical therapy, and that was about the same time that I started writing this presentation, and I was also using an eye tracker and voice controls on my computer because I could not physically use my hands. So this is what that looks like. Okay, well, you kind of get the idea. You just look where you want to look, and then you say click, or like hold and release, and then you just, there's like a phonetic alphabet. So how did I make amazing slides without using my hands? It was pretty easy. So please give a hand to my hands. This is Caleb Thompson, who also, he lives in Austin. He previously worked for ThoughtBot, and he now works for Heroku. I also want to give a thanks to my voiceover artist, Yuri.
Hello, I'm Yuri. I'm a Japanese voiceover actress. Today I will be playing the voice of the rabbit.
Yes, so there will be a rabbit in this presentation. I explicitly added this slide because some people were very confused about who the voice of the rabbit was. I also explicitly showed my children because at one point in time somebody thought the voice of the rabbit was my daughter, which I do not have a daughter. So I maintain Puma, the Puma web server. We had just released Puma 4, and the code name for Puma 4 is 4 Fast, 4 Furious. I recommend you use it. And this talk is mostly about performance. So before I really get started, I want to announce that I did find a way to make Ruby faster in general. So it's kind of exciting. I think it's gonna really wake you up. It turns out that you can just remove the sleep from your programs. And then this is Matt's, he created Ruby. So, yeah, that kind of fell flat. It's okay. This is a casual environment. So who knows who this is? Okay, so this is Marie Kondo. She is a world-famous tidying expert, best-selling author, and she has a television show on Netflix. I wanted to show you a little clip from a new show that she's working on. Marie also loves Ruby, and she loves performance, so let's take a look.
She looks excited. I'm so excited because I love
Object allocations. Object allocations.
Oh, I want things to be more simple. I don't know how to fix it.
Object allocations.
Oh my God, we have too much stuff.
I mean, I think it's going to be a hit. It's definitely going to be better than the Defenders for sure. Sadly, though, Marie couldn't be here tonight, and so instead we have the next best thing. We have her pet rabbit, and so I would like to introduce you to Con Hare.
こんにちは、皆さん、ようこそ。私はコンハレ。英語で春はうさぎって意味なんだ。うさぎはどんどん速く進むのが大好き。Hello and welcome everyone. My name is Kon Hare. In English, hare means rabbit. Rabbit loves to go really fast. I love colors, so I love Ruby. I also love performance. Today, you're here to hear the Kon Hare method of tidying your Ruby applications.
Yeah, that's great. Can you tell us a little bit more about what this method is?
First, take all of your object allocations and put them in a pile where you can see them. Consider each one as a sparks joy. Finally, keep only the object that sparks joy.
So how do you know if an object sparks joy?
If an object is very useful and keeps your code clean and it's not causing performance problem, then it sparks joy. If an object is absolutely necessary and removing it from your code causes it to crash, then it sparks joy.
That last one's kind of like a technicality.
When we put all the objects in front of us, it will help to determine which ones we can consider getting rid of.
Okay, so I see where you're going. To put our objects in a pile, we're going to need two tools. First is Memory Profiler, which is a library and a library that I wrote that helps you run benchmarking code against your Rails applications called derailed benchmarks. So first we're going to start out with a little audience participation. Get you warmed up. And go ahead and stretch if you need to. Stretch those arm raising hands. Here's a benchmark of two methods, and both of them are going to determine the largest of two values. So this one is going to allocate an array, and this one is going to do a direct comparison. So which do you think is faster? Do you think the array version is faster, that allocates an array in the talk about reducing object allocations? Or do you think the comparison version is faster? All right, okay, good. I will tell you the comparison version is faster, but does anybody know by how much faster? Just shout out a number.
50%. 1,000.
50%. 1,000? Oh, 42. Oh, that's a good one. It's over 9,000. Pi, anybody? So I will tell you that it's about 2x faster. So it's doing literally exactly the same thing, and we can rewrite our code in a way that makes it two times faster without changing the end user logic. So in general, touching memory is slower than doing calculations, than performing comparisons. And this is true of all languages, not just Ruby. If you've ever that malloc is slow, don't allocate memory. And so it's true with other languages as well. And since we know that Ruby allocation is expensive, we can optimize our code by removing those allocations, as we did before in our quiz. There are ways that we can use fewer objects, and it means our programs are going to run faster. Now, if we find in our program where we're allocating lots of objects, then that's going to show us a hotspot that we can optimize and potentially make things faster. Now, in general, the percentage of objects reduced roughly correlates to a performance improvement. So if I can reduce allocations by about 1%, then I can usually make the program about 1% faster. And that simplifying assumption also helps us to benchmark our code faster. Typically, whenever you're running a benchmark, you can't just like time your code before and after. Timings are very, they have a lot of variance. They move all over the place. And so you have to run that code thousands or millions of times and run it on both sides before you can actually compare them. versus measuring memory is extremely consistent. So you only actually have to run the before and the after once to see if you move the needle. So that's going to allow us to prototype faster, but we do have to be a little bit careful. We do have to go back and always make sure to measure the total speed of our performance change. Because in the process of changing our code, we're going to be adding logic, and we want to make sure that the addition of that logic does not outweigh the removal of the memory. Another thing to mention is that in Ruby, a lot of people are focused on number of objects allocated. That to me is less important than the number of bytes allocated. If you were allocating one object that has a lot of bytes, then that is worse than allocating one that has fewer. So that's just my personal opinion. And
Excuse me? Weren't you supposed to be telling people how to get all their objects into one place so we can use a Konghare method?
Okay. All right, so sorry, I got a little off track. So let's take a look at that right now.
Okay, be back in a hop.
Come on, people, back in a hop. So the memory profiler gem is going to allow us to take all of the allocations for our program and view them. Behind the scenes, it's a nice wrapper for the object space allocation tracing. If you're trying to profile a Rails application, you can use derailed benchmarks. The gem will hit an endpoint in your application and profile it from the CLI. The benefit here is that you don't have to start your server between tests. You don't have to refresh the browser to get results. Just, go up on your CLI, because we all hate typing commands, and hit enter. So we are going to look at a real-world case study of these tools, but to get started, I need a little bit of an introduction. Thank you, Aaron. I call this section inadequate record. All right, so first you'll want to run derailed benchmarks against a real-life application, and that's going to give you a pile of all of our memory allocations. So this, that's our pile of memory. That's a lot of memory. The output here is going to be showing the most memory allocations at the top, location of the most memory allocations. And so I start by looking at each file, starting at the top. And in this case, I've already looked at several, so I'm just going to go ahead and start at this, attribute methods.rb. Once I picked a file, I need to zoom in to get some more information. Here we're rerunning the same command, but now we're telling derail that we want to filter and only look at that specific file. With our filtered output, you can see that the output is a little bit cleaner, and it looks like the majority of our allocations are coming from line 270. Yeah, right there, 270. So let's figure out the code by taking a look at that. All right, so this is line 270 of that file. It looks like it is, I'm gonna try to increase my font size. Oh yeah, there we go. So it looks like it's allocating strings, but why? Why do we need this code in the first place? To understand, we have to understand what the code does. Oh, sorry, font size is too big. No, I can't read all of mine. There we go. You know I'm breaking the fourth wall. It's broken. We can't put it back in duct tape. Anybody? Anybody? Okay. No, sorry. All right. So this code, this allocation is happening inside of a method called respond to. And when we call respond to on an object, we want to know if a method by that name exists. Because active record is backed by a database, what it needs to know is if a column by that name exists. Typically, when you call respond to, you pass in a symbol, but in active record, all of the columns are stored as strings. So on this line, the symbol that we pass in is converted to a string, and then the column name array is iterated over to check and see if one of the column names matches our string. So for example, if we call respond to on a user, then we pass in email as a symbol. The symbol is converted to a string, and then we check and see if that matches a column. Or that column until finally, okay, we found a match. Then we can check if the object has an attribute with that name, and now, now that we know what that code does, we can ask, does this object allocation spark joy? It's in use, so it's useful. It's doing a lot of allocations, so it's not very performant. Does it help our code be cleaner? I mean, not really. Now, is it absolutely necessary? That's kind of the key question here. We don't really know yet, so let's find out. Let's see if we can refactor this code to make it faster while also maintaining correctness. Okay, so looking at this code, the name variable has to be a string because the database columns are stored as strings. So we have to make a conversion somewhere. My hypothesis is that instead we can find a way to perform a column check with a symbol directly. To me, this allocation does not spark joy. I think we can go ahead and just throw it away in the trash, and we never want to allocate a string if we can help it. So let's go ahead and get rid of the code.
Wait. You're forgetting something.
Yeah, like what?
You must honor this code before you get rid of it.
Ah, okay, that's a very, very good point. This code has been in hundreds of thousands of production applications for many, many years, and even if it does not spark joy currently, it has served a purpose, and for that we have to be thankful. So, thank you, code. We can now go ahead and get rid of it. Unfortunately, if that's all we did, then our applications would break. So we have to find a way to convert our symbol to a string without allocating. So we can store the column information as a hash with the keys as a symbol and the values as the string. And then we can use that hash to both check for presence and existence, and to also return a string value, which we're going to need to use in the has attribute method. We also get a bonus performance bump because the hash lookup is faster than having to iterate and check through each one of the elements in the array. Now you will note that we are calling toSim over here, and that's fine. That's not allocating because we're calling toSim on a symbol. Most of the time this is going to be a symbol, and calling toSim on a symbol does not allocate a new symbol, it just returns itself. Alright, so the patch reduces object allocations by about 1%. But is it faster? On average, the patch also caused render times to be about 1.01x faster. So, I mean, that's basically like 1% faster. And so I think with this code anyway, we're pretty much done.
You are so lazy. You're not done yet. You have shown that it is faster, but you have not shown that these results are statistically significant. It is time to teach them the t-test.
Okay, alright, good, thank you. So who here knows what this is? Nobody? Nobody? Congratulations, you have passed the t-test.
Yeah, thank you.
It's a T, that was the test. Oh, I can't believe you let me come up here.
Our last guy, quit.
You know what I'm talking about.
You too?
Those are the benchmarks.
Okay. Alright, so here is an example of code and how numbers can lie. We've got two objects, a string and an array. If we duplicate each object, we can actually see via Memory Profiler that they're the same size in memory. So 40 bytes and 40 bytes, which is the default size for an object in Ruby. So pop quiz, which is going to be faster? Duplicating an array or duping a string? As you can see from these results, that duplicating a string is going to be slower. And then we can just wait. Okay, so just kidding. Duplicating an array is going to be faster. Actually, yeah. So it turns out that neither one is faster, and that they're both about the same. So I could lie and just pick one of these, right? I could just show you, like, here's the benchmark. This one wins. We're faster. but instead we can use something called, we can use a statistical significance check to determine that I'm not just lying with numbers. So one of the ways that we can do that is with a thing called student's t-test to determine if our numbers are statistically significant. So this is William Seeley Gossett. He invented the student's t-test in 1908. Gossett worked for it's got a little thing in there, it's supposed to do that. It's like a nitrogen ball. These are dirty anyway. Who worked for Guinness. So why is it called student's t-test? If Gossett published it. Well, Guinness didn't want their competitors to know that they were using it. They were worried that their competitors would start using the same techniques. Oh yeah, forgot about that animation. So the problem that beer makers have is that the quality of their ingredients directly affects the quality of beer. There's only like 5 ingredients, so if one of them is bad, the beer's not going to be good. And so Guinness needed a way to compare 2 shipments, and they can take a small sample and say, oh, is this sample good or bad? And then they can take a small sample from here, and they can say, is this good or bad? But maybe that sample is an outlier in that shipment. So they have to take a whole bunch of samples over here and a whole bunch of samples over here, and then ask, is this whole shipment better than this whole shipment? And that's what they used. That's why he was working on the student's t-test.
This history lesson is interesting and all, but let's get back to object allocation.
Okay, fair. All right, I was a little bit of a tangent there. So I use a advanced statistical programming tool set. It helps you to excel. There's a function in there called t-test. I just used it. If the result is under 0.05, it means that there is a 95%. You are 95% confident that these 2 results came from different sources. They're not just. It's not just random chance that one is faster than the other. So you can say that they are statistically significant.
Well, was your change statistically significant?
Yes, so it got merged in. Yay!
But 1.01 times faster isn't much to brag about.
Come on.
You need to get 10 pull requests merged into make the program 1.1 times faster.
Hurts a little bit. But it is a 1.01 times speed up at the request level. It's not a micro benchmark. So theoretically, if we needed 100 servers to serve our application, now we only need 99. So that's pretty cool, right?
That's a good point. But still, it's only 1P off. Let's show these good people another example of using my world-changing hiding method.
What do you say? You want to see another one?
Yeah.
All right. Okay, what's the first step?
First, collect the object in one place.
Okay, so here's our pile of memory. Like before, I started at the top and worked my way down. Let's zoom into this file and see if we can make anything faster. This time we'll be taking a look at active models timevalue.rb. It looks like the memory is coming from right here from line 72. Let's open up that file. On line 72, what we are doing is we're matching an input string with a regular expression. Can you all see this? Do I need to dim the lights? I mean, the contrast is not like super great, but yeah, I mean, just listen to the sound of my voice. Imagine the code that is showing up in your head. Okay, so it allocates a bunch of memory because this generates grouped matches. So that's what later on we have $1, $2, $3, $4. So those are all objects that get allocated every time this regular expression gets used.
Now, does this object allocation span joy?
Well, before I can answer that, I have to find out what it does. What does this method do? Okay, so it accepts an argument. It's helpfully named string. I assume it's a string argument, not always. It returns a timestamped object based off of the string parts. So, can we make it faster? Well, on this line we're passing the regex matches to another method called newTime. And I don't think there's a lot to optimize there. We're basically just calling 2i, which is pretty fast. But what's going on this line? So regex match 7, the $7 here, will return a string that starts with a period, starts with a dot, and then has some numbers. And what we want from this is after our code runs, we want to know how many microseconds were in that string. So really, you know, it kind of just like strips the period and like turns it into an integer is what we're doing here. Except instead we're multiplying it by 1,000,000, turning it to a rational, multiplying it by 1,000,000, and then turning that to an integer. So we can do this a little bit more efficiently. We can guard against the most common case, which is when we have a string that starts exactly with a dot and ends with 7 digits. So first we move the leading period, then we convert that string directly to an integer by just calling 2i. Is it faster? Here's a micro benchmark. When we run it, we see that yes, it is indeed faster. It's 1.27x faster. So is that all we can do here? Oh, sorry. Is there more we could do here? I was like, man, that does not make sense for what I know the next thing is going to happen. Is there more we can do here? Yeah, I don't think so. I think we're just done. Let's just hit the bars. Let's call it a night. And
Don't give up now. You practically know nothing about how this method is used.
Okay, great. That is so true. So let's put in some debugging statements in there and find out how this code is used. Why is this code even called in the first place? So here's one backtrace. I'll admit it took a lot of hunting to kind of find a good one, and so I'm not going to bore you with exactly how we got it. This is the exciting part. This is the this time method that we are optimizing is called while generating a cache key. So let's open that file. Let's open that integration.rb file. If we follow the stack trace backwards, we'll see what is happening is that active record is taking a string from the database and converting it into a time object. That's why we're calling that time method. This is then used to turn around and generate a cache version. So this is where it's called on line 99. This is cache version. We can go straight there. Conveniently, it's just at the below in the file. And this is where the bulk of that logic lives. This is our line from the backtrace that I was showing you earlier. And that's our culprit. This is what is causing that object allocation, in essence. So what is happening is the database adapters, such as the one from Postgres, will return their values as strings. All of the values are strings, and active record will lazily turn that string into the correct object it's supposed to be. So such as a timestamp, or an integer, or it doesn't have to do anything to strings. They're just strings. Actually, I'm not entirely sure about that. Don't quote me. And so in this case, we are taking the string, passing it to the time value method, and converting it into an updated that timestamp, and then we are using that time object to turn around and generate a cache version string.
Does that mean?
Well, It means that it might be possible to go and use the string directly that is returned from libpq. And here's what it looks like when it comes out of the driver. Here's the string you get. There's a updated at before typecast. This is a thing that you can use, and you can see it. And when we look at the version that we want, this is what we use for our cache version, which is updated at 2s, and we pass in musec, just a format that Rails has defined. And so if you look at anything, you might notice something, which is that effectively all that's happening is that you're stripping out the unwanted characters, and when you do that, you've got the exact same format.
Does this allocation bring us joy?
So let's take a look. Is it useful? Yes, caching is a very useful feature. Is it fast enough? I'd say no, because it creates a bunch of allocations. Does it make the code cleaner? Well, yes, unfortunately. The code we just looked at is extremely clean. It was like, it wasn't even one line long. It was like half of an if statement. So is it absolutely necessary though? No, it's not. We can directly convert from the string that the database is returning to a cache version without having to make the leap of turning it into a time object first. So let's take a look at how we can do that differently. Okay, my version is a little bit more complicated. We've got some guard statements. We've got some, there's a little bit of the existing code. There's some cyclomatic complexity. Okay, and the new methods that we've added kind of make it a little bit harder to understand what's going on. So it's not cleaner. That is certainly the case. Does that mean that the old code sparks joy? Well, it depends. It depends. And it depends on your judgment. So before we can decide that, let's take a look at the performance impact. The patch reduces memory allocation by 5%. Last time we did this, that other patch I was working on only reduces memory allocation by 1%. So it's a lot better. So is it performant? In terms of memory allocation, I would say yes.
What about performance? How does that 5% translate to speed?
Okay, right. So yeah, I was talking about memory allocation, but now we want to look at speed. Well, it turns out that this time conversion to this string conversion to time is actually very CPU intensive, and that changing the code makes the application up to 1.12x faster. So if you're playing along at home, the last one was 0.1, so it's like 12x more performance improvement than the other one. That 1.12x faster from a request response level works out to be about 12 fewer servers if you originally had 100 to serve your requests.
Wow! That's amazing!
Yeah, thanks. I thought so. Now we have to thank our old code that helped us for so many years, so thank you, old code. So with the two performance optimizations that we just looked at, along with some other ones that I don't exactly have slides prepared, that I've not shown today, we are seeing a total of 1.23x performance improvement, which gives us a total of 19 fewer servers. And that's kind of like buying 4 servers and, getting one for free.
Wow! That is amazing! So this technique is useful. Let's review.
Great, thank you. I'm glad you're finally on my side. So first we're going to take a look at all of your object allocations, and we're going to put them in a pile where you can see them. Next we're going to consider each one. Does it spark joy? And then finally we're going to only keep the objects that spark joy. So hopefully I've convinced you that object allocation hotspots are a good indicator of a place where you can make some performance optimizations. and now you're ready to go out and try some of these techniques on your own code and libraries.
私たちの話に来てくれてありがとう。Thank you for coming to our talk.
All right, yeah. Thank you very much. So, yeah, thank you. That was a very rehearsed talk. So it only took up 36 minutes. I don't know, do you want to do some activities? Do you want to just go to a bar? I have 3 more of these. I'll probably drink another one.
Does anyone have any questions?
Oh yeah, questions. Yes.
In the first refactoring, you were able to check if the column existed via a symbol instead of a string.
Yes.
Is that built into Rails?
I had to add it.
Okay.
Yeah, basically I added a method that takes that array, and the first time you call it, it builds a hash, and then every other time it memoizes it, so it just returns that hash. So yeah, that was the added complexity that I introduced, but that one cost of, oh hey, we have to build a hash the first time we call this is amortized over like every single request that active record responds to, it gets called a ton. Like especially if you're passing that object into a view helper for like caching, it's like, hey, are you an active record object? Like, do you respond to cache version? Do you respond to cache key? Do you respond to this? Do you respond to that? So it's a lot. Good question. Thank you.
When you're benchmarking and working on Rails here, what applications are you using to benchmark?
What applications am I using to benchmark?
And do you find that it varies, like looking at different types of applications, kind of those results you're seeing?
Yeah, so all of these were me on code triage and me optimizing specifically the front page of code triage, which all of these changes were, how I just mentioned responds to gets called a lot in caching. That's because the front page of code triage is cached. And that's why, the updated act was used in caching because the front page is very cache heavy. So yeah, these change, so I would say if you have a cache heavy page, you would expect to see kind of similar-ish savings. But yeah, it absolutely depends on what your application is doing. Especially when you start talking about like when you are in the real world use cases of an actual app. And so the other question of like how do you get the speed of, was that a question?
No, but I like where you're going.
Okay, so the question of like I showed you it's literally one command to just measure the amount of memory that this page is allocating. Originally what I used to do is derail benchmarks has a bunch of other commands you can run, and they're basically just a wrapper for other tools, and one of them is just regular benchmark, not benchmark IPS. So like basically go hit the front page of this website 1,000 times and tell me how long it took. And so what I used to do is I wrote my own script that would call that script 100 times. So 100 separate times I would hit the front page 1,000 times, see how long it took, hit the front page 1,000 times, see how long it took. I would do that before, and I would do that after. It takes about an hour to do that each time. And when I said I used Excel, I would literally copy and paste into Excel, and then I used that function to like compare and see the performance differences. And the reason why I want to take 100 different samples is to make sure that I'm not skewing, like I want to take a bunch of small samples and then I can use statistical significance comparisons to say, yes, these two samples are different. That got really, really time consuming, and so since I made the talk, but so I made the talk, and then I was like, oh man, this is really time consuming. I'll just bake this into Derailed, and so now Derailed actually has a method that just does that for you. So you run this one command, and you give it a git SHA of Rails before and after. So you're like, hey, I made, you know, locally I made this patch to Rails. And then in my gem file, you'll say path and like point it at your local checked out thing. And you can give it 2 different git SHAs, or if you give it no git SHAs, it'll just figure out the last 2 versions. It'll just assume the most recent was your change, and it will compare against the 2. And I tried to be actually pretty sneaky and I'm doing that, so I don't know a lot about statistics, by the way, at all. I like barely passed that in college, but what I did that was, I was like, oh, this is so clever, is while it's running, I'm doing a statistical comparison, because I mentioned it takes about an hour to run it, 100 times, 1,000 times each, so I bumped that down from 1,000 iterations to like 300, and then I was like, well, once it's statistically significant, let's just stop. And for like, if you're just doing, if you're just working and you want to go get the information as soon as possible, that's not a bad idea. But it turns out, like, if I showed this to some people who know statistics and they were like, that is not how that works. Don't do that. So I might need to change that. But yeah, to answer the question that you did not ask, it is a command in derailed benchmark. Yeah. And I've been thinking about, it would be very easy to build on top of that, to add another one that instead of comparing against 2 commit SHAs of a library like Rails, where you could compare 2 commit SHAs of your app. So like if you're working on performance locally, then you could compare that change. But currently, literally no one else is using that function or feature other than me, I think. It's documented. Check it out. But nobody's, yeah, maybe I'll write it. Anyway, yes.
Yeah, I guess I'm curious about like what you're running the initial derail command against to get those object allocation counts. Is that like a running production server, your local dev that's primed in some way?
Yeah, so so how derailed works is it loads, when you run derailed, it says, oh hey, you're in a Rails application directory. And in Rails, there's a file, I think like boot.rb or whatever, there's a file, you can basically just require it, and it loads your entire application into memory. And then at that point in time, your application is, you have access to like Rails, you can call like Rails.application, and it's a rack object. And so what derailed does is there's a thing called, I think it's rack mock maybe, it basically generates a fake request, and then derailed hands that fake request to this rack object that you have in memory, and it doesn't know that it's not actually being run as a web server. It doesn't know that it's not being booted. It just takes whatever the request it is and processes it and does whatever your normal server would do, and then just spits out the result. And so this is all locally. If you want memory allocation stuff from production, there's some APM services, like Scout does a really good job of showing memory per request. Also, I recommend, so Scout is a paid thing, you have to pay for it. It's like New Relic. I don't like New Relic, just from a user standpoint.
What does APM stand for?
I have no idea. It's yeah, I would believe that. The answer there was application performance monitoring. But yeah, just anytime you've seen a page and it's like, here's a slow request, and it's like production. Normally you have a gem that like takes results of your app and like ships it somewhere, and they like make it look all pretty. New Relic is the longest, oldest one. Scout, if you were really old, there was a cool one that was based out of Austin called 5 Runs. That was like that's like,
I remember that.
yeah, that's just like my OG cred right there. Skylight is actually pretty good. My 2 favorite are Scout and Skylight right now. But there's also a free gem that I love called Rack Mini Profiler. Did I mention it's free? You should just like drop it in your gem file right now. And what it does, whenever you load a page locally, it gives you a little it injects HTML into the result and just shows you like, here's how many milliseconds your app took. And if you click on that, it shows and says, here's how long all of your SQL statements took. Here's how long all of your view took. And you can add a query param to your URL. I forget what it is, but it's like, I'm just gonna make it up. It's like rack mini profiler equals memory or something, and it'll actually give you that output. The cool thing about rack mini profiler is it's extremely lightweight. It's a sampling profiler, and so you can actually run it in production. So for code triage, if you were logged into code triage as an admin, then I actually get that in production. You don't have to pay to see the memory allocations. And also I would say if you're working on your own stuff, in general, your app is slow because of the database. Because you were using the database wrong, maybe you're missing an index, maybe you are doing an N+1 query, which Rack Mini Profiler will help with, for sure. And then only kind of after that would I start looking at memory stuff. Memory allocation is a big one, and it helps to understand what does memory allocation mean, and what does it mean to use fewer objects. But stuff like calling user.all in your code base when you have 10 users is fine, but then you ship it to production and now you've got 10 million users, and it takes 20 seconds for this web page to boot. If you looked at that page with Rack Mini Profiler or Scout or one of these things, then you would see oh my gosh, I'm allocating a couple megabytes worth of memory, because not only is that query giant, but it has to take every single one of those query results and turn it into a user object. And you know what? Each user object has 10 different fields, and each of those fields is an object. And the way that Active Record works, with lazy casting, it's there's actually multiple objects per field. So that all kind of adds up fast. But yeah, if you're just getting into the performance stuff, I would say start with database stuff. There's a really good book called the Complete Guide to Rails Performance. I think it's Speed Shop. I'm not sure. Rails Speed. Rails.
Yeah, it's Nate Berkebeck.
Yeah, Nate Berkebeck. He came to Austin, did a class that I saw one of you here in. Yeah. Good person. Good job for that person. Not going to single them out. Yeah, I don't know. Did that answer your question? I kind of just rambled there for a bit.
It did. Thank you.
Okay, cool. Please hold questions. I told you it's supposed to do that. Any other questions?
I've got a sort of tangential one.
Sure.
So with the updated example that you showed, sort of implied to me that updated is lazily transforming that string into a timed object?
Correct. Yeah. So when you call dot updated that's when it says, oh hey, we've got this string, and it's not been converted yet. But then once you call it once, once you call it once, it memoizes it, and you don't have to pay for that again. So if you were using the updated let's say the page is showing like GitHub where it's last commented 1 minute ago or something like that, then you would not see that. You would not see that benefit because you're still having to make a conversion anyway.
Did you bring enough for everyone?
So I bought them right before I came, and I bought them at Quickie Picky, and they did not have any of those grocery store insulated bags. So I just kind of wrapped them in my semi-clean clothes. It's my swimming gear and workout gear. I mean, y'all want to get some cups? I don't want to take them home.
It'd be fun to watch you drink.
Then we have to drag him home.
Yeah, look, I did not. I did not like. Okay. Yeah, well, so I think my first childhood memory. But yeah, I don't know if you have any performance questions or contributing to open source questions, or there was a hand.
Yeah, so one of the challenges that we're running into some performance problems right now, and one of the challenges that we find is knowing where to look for what's going on, right? Is the problem that, you know, we're allocating all these active record objects because we're doing a big query and we're doing something stupid with it? If we replace that by just doing a test and, hey, we're doing just as many queries, but we're not allocating active record objects, well, is that better? Is it not? Maybe we can refactor the whole query and just do something better. Is the problem that we don't have an index in the database? Is the problem that, wow, we really ought to be doing some of the tempo caching here, but we're not? You know, it seems like there's so many levels that you can tune for performance. How do you kind of figure that out? Is that where Rock Mini Profiler and things like that come in? Or do you just say, well, I'm focused on memory this week, and next week I'm going to focus on profiling my database and improving my queries?
Yeah, so that's a really good question. I would say that, I guess I kind of want to meta comment on that, which is my experience with performance stuff is the more you do it, the better, like, obviously everything, the more you do, the better you get at it. If let's say you're on a team and of 10 people and you're like, hey, every Friday one person is gonna like optimize performance stuff, and you just take a rotation, as opposed to saying, hey, for the next 10 weeks you are gonna be the performance person. At the end of those 10 weeks, that person would have a lot better of a feel for kind of like, you know, that like this type of a problem smells like this thing. So I will say, just like in general, like a lot of it is sniffing it out. For getting started, I try to start as high level as I possibly can. For instance, like when you were asking, if you came to me and you're like, hey, I have problems with my app, performance problems, I would say like, well, basically like show me where it hurts. Like, why are you saying that? Is it because you have, you know, if I'm looking at a response time of your app, is it, they're all pretty good, and then you just have like one random spike, you know, and then it's, or is it, is the average across all of them not, you know, just not that great? Generally, if you can, the more focused you can be on a thing, like in the case where there is just one spike, like that's gonna probably be a little bit easier to go after. Let's say that was the case, I would want to know, okay, well, like give me the logs. What endpoint is that happening on? If I visit that endpoint, does that happen? Is it only when a specific user is logged in? Is it during a time of day? Like there can be, you know, there can be other complicating factors. Like one of the ones for that exact problem, one of the ones I had was so I hit that endpoint and it's fine. It's like not slow at all. I'm like, well, I don't know what's going on. And then I checked more of my logs around that same time and realized that my database load was through the roof. And what happened was I had a task that was only running once a day, doing a ton of database work, and that was just when the spike was. And so it was overloading the database. And so it's kind of like you start at a really high level and then you move down a level and you ask yourself a ton of questions, and it's almost like like a giant decision tree, where I treat performance debugging very much like I treat regular debugging of, you know, when you start, you have the world, the problem could be anything in the world. So it's like 20 questions. You want to ask the one question that eliminates the most results, and you kind of just keep on doing that again and again and again. You know, you might start, like normally you have to have a hypothesis. And my hypothesis in this imagined scenario is that endpoint is doing something bad. So if I go to the same endpoint and it also does something bad, then that's great. It proved my hypothesis was right. I can try to reproduce it locally. And like that's a good thing for me. In that case, the hypothesis was wrong, and then I had to look somewhere else, and that kind of narrowed that field down. And that's where some of that, just over time, you can kind of get a better sense for, okay, this is a better question to ask than not. Yeah, another thing for like, is this a problem? Like when I was doing all of these tests, like before, one of the steps I didn't show you is I would comment out code and run it and with a benchmark, and like sometime, yeah, I'm like, oh, you know what, removing this object allocation is going to be, you know, great or whatever, and then I would just like comment out all of the code inside of updated at, and so it's literally doing nothing. And I mean, sometimes that works, and sometimes it just makes everything blow up. But like, and that will kind of give you an idea of what's the maximum amount of savings I can possibly find from this area. And that way you don't spend too much time invested in going down the, oh my gosh, I'm going to get rid of all my object allocations, and it's like, oh yeah, okay, it was an index. Or, oh yeah, I should have cached or something. But yeah, that was a good question.
Anyone else?
I mean, seriously, we got cups up there.
When are we getting your Rails improvements?
So all of these were shipped with Rails 6, so upgrade to Rails 6. I do have one improvement that is not merged. It's got like a ton of thumbs up, but nobody from Rails Core will review it. So I did include that in the patch. And did anybody watch the RailsConf, Aaron Patterson's RailsConf keynote? So in the keynote, he mentioned that calling a view with caching is like 5x slower than calling it without caching. If it's a really simple view, basically. And so my other patch makes the current calling it with caching 1.8x faster. But in order to do that, I'm dealing with cache keys and a lot of stuff, and a lot of the code in Rails, especially when it comes to cache keys, is very legacy. And like if you make like if you make a mistake, then you end up like invalidating people's cache. If you make a mistake and the cache key you generate is different than the old cache key, then like, and somebody deploys that, then instantaneously like the entire application is like a cold cache. And like I know, I talked to DHH and Basecamp. He was basically saying that their performance is directly related to how long they can keep an object, a key, how long they can keep a key around. Yeah, there's this like feature called key recycling that they implemented, and it went, their cache used to turn over like, I'm just gonna make up numbers, used to turn over like every 10 days, and they went for it like turning over every 30 days, and like that dramatically improved CPU performance, because that was just all, you know, every time it invalidates, they have to re-perform that calculation and then re-cache it. And so it's, if you mess up something in caching, like performance-wise, it can be pretty bad. So.
Do you know what they changed with regards to reusing the cache keys? I know that.
Yes.
Okay,
Yeah, I found some major bugs in it.
okay, so I know that Basecamp's main idea is that each of the individual views is cached.
Yeah.
But if you were to reuse those keys, they basically changed the key to expire the cache and just let it fall out during its cleanup, as opposed to making new cache keys.
You all.
We got time.
Okay, you got time. So I hope this is, nope. Yeah. All right. We're gonna do this the new-fashioned way.
How is it moved before I don't know.
Okay. I don't know why that just happened. Here we go. All right. So /1. So back in the day, when you would, let's say you have a view of, you're going to show your users and you want to cache that. So I mean, normally there'd be some other things here like views slash, home page or whatever the like homepage HTML, that kind of a thing.
I don't think it's
You're trying to share.
Ah. Here we go. I'm glad. Thank you all for not just like letting me do that for 10 minutes.
Can you shove the board out of the way now?
Oh, sure. Good call. Okay. So, to start off, I'll just say, like, in general, inside of Rails, what we're talking about is you'll have a view, and you can say, like, is it cache?
Yeah.
It's like cache, and then you'll say, like, add user, do, and then, whatever happens in here, if it is in cache, it doesn't run, it just gets pulled from Redis or Memcache or whatever. So that's what we're talking about. And how all of those work is you just say, hey, Memcache, give me whatever is in this key. You just give it a string. And normally it's, people kind of make like a file directory sort of a structure. And so what used to happen is, let's say you were getting the first user. So you would do like user/1 and then maybe a dash and then the updated of that user. So like 2019, what is it? 09, 30, blah, 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 blah. And then like this works every single time the page is called, it generates the same cache key, it gets a hit, it renders that. Now if you call like at user.name is equal to, you change it, give me a name.
Wow.
Okay. Now the cache key is changed to, something new. 2020. Hey, I don't know how Rails generates the cache keys. And but the way that this works is it doesn't actually invalidate this cache key. This cache key still is alive. And what happens is you can set up memcache and you say, hey, delete my oldest cache keys first. And so whenever you create this cache key, it's fine, another cache key got deleted. And then way down here, you create another cache key, and it's like, you know what? I bet we're not using that anymore. So it gets rid of it. The problem is that that keeps on happening, and keeps on happening, and keeps on happening, and eventually it's going to be like, oh, I bet we're not using that. And it's like, yes, I am. Like, I haven't updated that user. Don't get rid of it. And it's like, too bad, we got rid of it. So that's the way old caching used to work. So how new caching works is that we got rid of this. We got rid of that. Updated that, and let's see. Let's say this used to say hello world. So we get this cache key and it returns hello world. So that's what it used to do. Now what it does is it actually takes this value and it puts it inside of the cache. And so what Rails does is it says, hey, give me whatever's in this cache key. Don't care, whatever it is. It'll return this, and this is, I know I shouldn't, it's awful when I just make up numbers on the side. 2019, this is the updated at string. And it will check this and say like, hey, is this updated at the same as, this at user? If it is, it'll use it. If not, it will throw it away, regenerate it, and shove the results back into the exact same cache version, exact same cache key with a different version. So yeah, in this scenario, let's say, you know, we change the name on the user. It will use the exact same, thing. So in this scenario, it'll pull this cache key. It'll say, oh, hey, here's your updated at, and it'll check it against the user. And so yeah, that's how that works. And the performance benefit is it just has your cache keys cycle less, because instead of just waiting for it to fall out of the cache, you're just reusing the same one. And because you're touching, yeah. Anyway, cool.
Is it a string that's encoded?
Yeah. All of the caches just use a string. Well, you mean on the value that you get back?
It almost looks like a hash with the key value, and I know Redis supports that, but I don't believe it would support something specifically for Redis.
No. Yeah, the way that Rails does it is each different adapter it has, they have written their own. They've written their own adapter. And the way that they actually do it is they create an object, view cache, and then that object has like cache version. It has properties, and then they marshal it. Yeah, I can't represent this well. Just listen to my words, not my screen. Yeah, they just call object.marshal, which gives you a string representation, and then when they get it back, they unmarshal it, and they ask it and say, hey, what was your cache version? Okay, great, give me your data, or no, I'm gonna just throw you away and make a new one. Which, in my opinion, and I'm trying to like reduce object allocations, like it's a lot of extra object allocations. You get the raw string from the thing, then you like have to unmarshal it, and then like, yeah, anyway. Not how I would have done it. It's fine. It's too late now.
I guess I have a tangent about understanding how their change actually improves things, given my understanding of how cached and Redis work.
Yeah.
My understanding is that they are using like least recently used algorithms to determine what keys you're actually accessing before evicting things.
I'm listening. I have this bad habit where I do this.
That's okay.
I promise I'm listening.
And I guess I'm wondering how like recycling keys like this actually prevents you from, I guess it reduces memory pressure some, but I don't understand how it actually improves performance.
So I wrote a blog post about this actually.
Sweet.
If you just Google, whatever I just Googled, Schneem's Heroku cache. So the reason I know a lot about this is I found a bug and had to figure out what was going on and fix it. And like there's, oh hey look, there's some examples. You can kind of see, you know, what I was talking about with cache versions. Yeah, so the reason that this is better is like let's say 2019-1. Like let's say you update it, you save a new object, okay, new cache key. You save a new object, new cache key. Like you save it, new cache key, you save it, new cache key. That's the old method. Now, like with the new method, is like, okay, you save it, all right, you save it again, okay, you save it again, okay, you save it again, all right. So just it generates fewer cache keys. So this is still going to get pushed out of the cache eventually, but this, this is going to get, All right, here, users 2. That's just to show that's a different one. So in this scenario, this one would keep on using the same one, and this one would keep on using the same one. But in this scenario, like, the different key gets pushed out faster. I don't know if that is.
My question is, like, if the different key is being accessed, it actually like has a more favorable position in the like LRU cache, and thus will not get pushed out because those like 4 stale user 1 keys are not being accessed presumably.
I think the majority of them are not access based, but it's the time of writing. Now I could be wrong. Maybe there could be a setting for that. But I think you would have if you were doing the time of reading, you would have the problem of if you were. Yeah, actually, I guess that could be interesting.
I've been looking at memcached issues like the last week, so.
Oh yeah.
So fresh in my mind.
Wait, is the idea that let's say you had like the cache capacity of like 100 keys or something, and then say you had even if you had the access method where it's like, I last accessed this one like 100 accesses ago or whatever, and then you like have another thing that you want to cache, but even though you still want all of those 100 things to be cached, like it still has to get rid of one because you have like that limit, right? So it seems to me like the issue that this is kind of solving is that it just like you said, it like reduces the pressure on it because it's like you don't have as many, so it takes longer to reach that cache. But so what I don't understand though is like okay, so that makes sense to me, but isn't the point of having like a limit on the cache keys to like conserve memory, right? I assume like space, right? Like reduce the amount of space that you're using. Maybe I'm wrong about this, but so is it the case that in each of these cache keys they have like the value of that key is a hash itself with the updated at strings as the keys of that hash and then the values.
So keep in mind that whatever's in here is like literally an entire web page.
Okay.
Like normally the amount of memory usage is not from the key itself, but whatever you're storing in there.
Okay.
And so it's all like, hey, this cache is going to run out of memory. We want things fast, so we want them to stay in memory. And actually, so some of you might be like, hey, I've never used caching really before, or like, how did Basecamp even notice that this was a problem? Like from the question earlier, if you're doing performance stuff. This is really obscure. Like you would basically never, like the problem with this is you would, like this is kind of like systems administrator, like DevOps, like DBA type stuff, where if you were looking at your memcache, you might say, you know what, like our memcache is like turning over pretty, like, why is it turning over so frequently? And you would also have to know that if you went from a 10-day turnover to a 30-day turnover, that would mean, like, when Basecamp switched to this, like, the number of servers that they were able to use to, like, serve Basecamp went, like, way down. I didn't talk a lot about this because, honestly, this is confusing. Like, like NY, and it's kind of unseen. Like, if you really wanted to get into like the nitty gritty of like systems debugging, Brendan Gregg is like a really good person. Brendan, Gregg. I think it's Brendan. Brendan. But yeah, this is from like, you know, I said take the highest view possible. Like this is not looking at one server or one request. Like this is looking at the entire architecture. And you know, if you really like performance and you get into this, like you might end up looking at your memcache things. And also, I guess another thing to say is that this is not, like performance stuff in general is very much like Henry Ford, the famous Henry Ford.
Fast and horses?
No, or was it Henry Ford or Thomas Edison? Okay, sorry. I'm working on a couple Guinnesses here. Are we still streaming? I think it was Henry Ford. Somebody, anyway, where they called him in and said, okay, hey, I've got this problem. Came in, made an X on the boiler with a piece of chalk. Took 2 seconds, and then invoiced him for like $1,000. And it was like, hey, what's going on? And like, or they didn't invoice them. They're just like, pay me $1,000. And like, you need to send me an invoice and like itemize it because like $1,000 it took you 2 seconds. And they came back and then they said like making the chalk mark like $1, like knowing where to make the chalk mark $999. So some of this does sound fantastical and magical and like, oh, like, you know. I can't believe he knew to do that, or look at this thing, and it's like honestly it's just a matter of like time and effort, and also like standing on the shoulders of giants and like finding other people who are doing performance work, and like anytime one of them is like like oh my gosh, I made this thing like so much faster, and you're like, why or how, and they're like, oh, I reduced my cache churn, and you're like, that makes no sense to me, like tell me about it. And you keep on asking questions until you understand, and then eventually you're gonna go back and like try it with your code, and you're like, wow, you know, that worked, and then that's like a thing that you're gonna have in your back pocket like forever, and you're gonna understand the systems a little bit better. It's a very like time-consuming, long process, and I'll also add that I kind of got to a point in my career where I felt like I needed to specialize a little bit. And I was like, hey, I could get into security or I could get into performance. Those were kind of the two. I'm not going to tell you those are the specializations you should get into. But for me, that was like what was in front of me. And I was like, you know, when you make something faster, like the first thing I do is I turn around and I'm like, hey, Twitter, I made this thing faster. Like when somebody hacks you, you're like, hey, Twitter. Can't talk about it. Yeah, and I think just for me personally, like a lot of the tooling and the developer experience of Ruby is really great. Unfortunately, like I'm not gonna say that Ruby is slow, just like Active Record, and I'm not gonna say Active Record is bad. It's so powerful. It is such a sharp tool. It is really easy to like. Your application is so cut up and performance bloodied that you don't even know it. It just like there's all of these objects and all of these things, and I'm going to attribute that to a power issue, not a design issue or language issue. Like again, the vast majority I would say of performance problems come from just like poor use of the database or just looking at your data stores. But the reason I really like talking about this stuff is like I want more people to talk about this stuff. I want to talk to more people about this stuff. Y'all are great.
Thanks for coming. Help yourself to pizza. Does anyone interested in going to a bar? Raise your hand. All right. There's a bar right across the street called CU 29. Is that right?
Yes.
Yes. That's a good place. It's just right here. It's within walking distance.
Oh yeah, I'm glad it worked out.
I think I know what the key might be. It might be for like that 95th percentiles type stuff where like on a multi-tenant app, someone's